Electromagnetic waves. Question 5 from the March 2018 Common Test. Physical Sciences, Grade 10. Question 5. The following are some electromagnetic waves and their corresponding wavelengths. A table with two columns is shown. Column 1 shows the type or the name of electromagnetic radiation. Wave Z, X-rays, ultraviolet, visible light, and infrared. Column 2 shows the wavelength in meters. The wavelength of wave Z or Z is 5 multiplied by 10 raised to the power of minus 13. The wavelength of the X-rays is 2 multiplied by 10 raised to the power of minus 10. The wavelength of ultraviolet is 3 multiplied by 10 raised to the power of minus 7. The wavelength of visible light is 5 multiplied by 10 raised to the power of minus 6. The wavelength of infrared is 4 multiplied by 10 raised to the power of minus 5. So we are given those wavelengths. Question 5.1. Name one source of ultraviolet radiation. The sun is the biggest source or producer of UV radiation. So to answer question 5.1, we would just write sun. This is a 1-mark question. Question 5.2. Name the radiation that is used to observe objects and people in the absence of light or in the dark. Infrared can be used to see in the dark. For example, you can put on infrared glasses in the dark and you will be able to see the heat signals that an object emits. We cannot see infrared light, but we can sense it as heat. So to answer question 5.2, we would write infrared or infrared, and this is a 1-mark question. Which one of the above waves has the highest frequency? Use the data in the table to explain. That is question 5.3. The wavelength shows a pattern or a trend. It is increasing as we move from wave Z or wave Z to infrared. Wave Z has the shortest wavelength of all electromagnetic waves shown in this table. The wavelength is 5 multiplied by 10 raised to the power of minus 13. Infrared has the longest wavelength of all the electromagnetic waves shown in this table. It has a wavelength of 4 multiplied by 10 raised to the power of minus 5. The wavelength of a wave is inversely proportional to the frequency of the wave. This means the longer the wavelength, the lower the frequency. The shorter the wavelength, the higher the frequency. So this means that the frequency increases from infrared to wave Z. Wave Z has the shortest wavelength but the highest frequency, and infrared has the longest wavelength but the lowest frequency of all the electromagnetic waves or radiation shown in this table. So we would answer 5.3 by saying wave Z has the highest frequency because the wavelength of a wave is inversely proportional to the frequency. Look at the underlined words. Those are your keywords. Those are the words you need to mention in order to get full marks. This is a 2-mark question. You will get a mark for writing wave Z and another mark for mentioning the inverse relationship between wavelength and frequency. Question 5.4. Calculate the frequency of ultraviolet light. This is a 3-mark question. The wavelength of UV radiation is given in the table as 3 multiplied by 10 raised to the power of -7. To calculate, we need to first figure out the quantities that we are given, that we know the values of. From the table, we know that the wavelength value is 3 multiplied by 10 raised to the power of -7 meters. The speed of electromagnetic radiation in vacuum is a constant c with a value of 3 multiplied by 10 raised to the power of 8 meters per second. We need to calculate the frequency, and that frequency must be calculated in hertz. The expression that relates all these quantities, the wavelength, the frequency, as well as the speed, is the wave equation C equals to F times lambda. And this is where your first mark will come from. So to calculate the frequency, we need to rearrange the terms of that wave equation that we provided just now. And we will use this little triangle to derive. From this triangle, we can see that the frequency F equals to C divided by lambda. This means that the frequency F is given by the speed of electromagnetic radiation divided by the wavelength of electromagnetic radiation. Now it is just a matter of substituting the known values for the speed and the known values for the wavelength. So we get that F equals to 3 multiplied by 10 raised to the power of 8 divided by 3 multiplied by 10 raised to the power of -7. And we get the answer as 1.5 multiplied by 10 raised to the power of 15 hertz. So you get your first mark for providing for doing the correct substitution, and your final mark for the answer. Question 5.5. Define a photon. This is a recall question in which you need to recall or remember the definition of a photon. It is a 2-mark question. A photon is a packet of energy of electromagnetic radiation. Sometimes you will hear that a photon is a packet of energy of light, but I don't like this definition because it is not inclusive of all other types of electromagnetic radiation. Yes, we have light photons or visible light photons, but we can also have X-ray photons, gamma ray photons, UV photons, etc., etc. Question 5.6. Calculate the energy of a photon of X-rays. We are given that the wavelength of X-ray radiation is 2 multiplied by 10 raised to the power of -10. And we need to figure out the energy of these photons that this X-ray has. So that packet of energy, how much is its value? We are given that the wavelength lambda is 2 multiplied by 10 raised to the power of -10 meters. The speed of electromagnetic radiation in vacuum is C, which has a value of 3 multiplied by 10 raised to the power of 8 meters per second. We know that Planck's constant H has a value of 6.63 multiplied by 10 raised to the power of -34 joule seconds. And we need to determine or to calculate the energy, and that energy we must calculate it in joules. Everything is in the correct SI unit, and we must calculate the energy. We will solve using an expression which relates all these 4 quantities together, and that expression is E equals to hc divided by lambda. We then substitute the known values of h, of c, as well as of lambda, so that we have E equals to 6.63 multiplied by 10 raised to the power of minus 34, which is multiplied by 3 multiplied by 10 raised to the power of 8, all divided by 2 multiplied by 10 raised to the power of minus 10. Remember, opening your brackets on your calculator is especially important when you are working with very small numbers. Planck's constant is a very small number. Working with very big numbers, the speed of electromagnetic radiation in vacuum is a very big number. So open those brackets. They will make sure that you do not get the wrong answer. So if you do this and you put this in a calculator, we find that the answer is 9.95 multiplied by 10 raised to the power of minus 16 joules. So this is where your first mark will go for providing the formula or the expression, identifying the right wavelength from the table, substituting the correct values into the expression, and now the final answer. So that is your 4 marks. Question 5.7. Identify the electromagnetic radiation labeled Z. What is wave Z? Think about it for a minute. This is a 1 mark question. To answer this question, you need to remember, you need to have memorized the arrangement of electromagnetic spectrum, or the arrangement of electromagnetic radiation on that spectrum in order of either wavelength or frequency. The electromagnetic radiation in this table are arranged in terms of decreasing wavelength, from the shortest wavelength, which is wave Z, to the longest wavelength, which is the infrared. Wave Z is an electromagnetic radiation with a smaller wavelength than X-rays, and there's only one. In the whole electromagnetic spectrum, there's only one other electromagnetic radiation which has a smaller wavelength than X-rays, and you need to know, go memorize it, go memorize that electromagnetic spectrum before you go write your March control test. And those are gamma rays. So gamma rays have the shortest wavelengths of all electromagnetic radiation. Thank you so much for watching.